There are a number of ways of getting sound out of your Raspberry Pi and Raspberry Pi Zero. So in this episode we're going to look at I2S digital sound output. So let's see how it's done. Hi and welcome to Bytes and Bits. There are a number of ways of getting sound out of your Raspberry Pi and especially your Raspberry Pi Zero. And in a previous episode I looked at using the analog sound output and recreating the headphone socket and then off into a loudspeaker. In this episode, we're going to try and get slightly better sound quality by using the Inter-IC sound system, or the I2S, which is a digital sound signal primarily designed to send signals around circuit boards. But we have that available on our Raspberry Pi Zero, and hopefully that will give us a bit of a cleaner sound. So let's find out a little bit more about I2S and then implement it on our Raspberry Pi. So what is this I2S signal? So I2S or IIS, or whatever way you want to call it, it stands for Inter-IC sound. And it was designed as a way of sending sound information between parts of the circuit board, so we could send it as a digital data stream and therefore avoid all of the noise issues associated with sending analog signals around our circuit board. To send the sound signal, we need a minimum of 3 signal wires. So one of these acts as a bit clock to synchronize the individual bits of data. One of them acts as a left-right channel clock, which specifies whether the data being sent is actually for the left speaker or for the right speaker. And the final one then is a data wire, which actually sends the actual digital data. So on all of our Raspberry Pis, the GPIO header provides all of these data signals as Alt0 functions on the GPIO pins. So GPIO 18 will be our bit clock, GPIO 19 is the left-right clock, GPIO 20 is a data input, and then GPIO 21 is our data output. So in our setup, we don't need the data in connection, as the Raspberry Pi will only be sending sound out and not receiving it from other devices. To actually get some sound, we need to convert these digital data signals into some analog sound waves. So we're going to need some external hardware to perform that function. So the first thing we need is a digital to analog converter, or a DAC, and this will take in the I2S signals and convert that then to an analog stereo sound signal. Now we want to be able to have both a headphone output and a loudspeaker output for our handheld gaming device. So we'll need this first stage to provide a signal which is suitable for our headphones rather than being a fully amplified signal for a loudspeaker. If we do go all the way to a loudspeaker signal first, then if we try and plug headphones in, we do run the risk of burning them out. So we need to feed this first DAC stage into a headphone socket, and that headphone socket will allow us to plug in our headphones so we can listen to the sound at that level. We then need to take an output from this headphone socket and feed that into an amplifier stage, and that will do the full amplification then so that we have a signal which is powerful enough to drive our speaker. So the circuit I'll be using to test all of this out is shown on the screen at the moment. Now in this one I'm using 2 ready-made modules from Adafruit, and one of those is going to be the I2S DAC, and then it's going to feed into an amplifier. So the output from our Raspberry Pi then is fed directly into this digital to analog converter, and that just simply converts that digital signal into our stereo audio signal. And the output from this one is at the sort of headphone or the line level, so it's able to directly power headphones but not an actual loudspeaker. The module itself actually does have a headphone socket built into it, but it doesn't quite work the way that we want it to. We want to be able to have the ability to plug in headphones and have our speaker turn off, and then unplug our headphones and have our speaker turn on. So we need a separate headphone socket to provide that functionality for us, and that's what you can see the output from the DAC being fed into. So in this particular headphone socket then, it has both an input side into it, which will feed directly through onto the jack plug, and then if we plug in a headphones, it will feed through to the headphones. But it also has the ability that when we have headphones plugged in, it has an output pins, and those get disconnected if it senses that there is something plugged in. So if we unplug our headphone, then the output stage gets reconnected back up to the audio signal, and if we feed that through to our amplifier, then we can power our speakers and have this ability then to either have headphones with no speakers or no headphones and then have the speakers being turned on. So the amplifier module then is, I'm going to use a mono amplifier, and this is the same as the one we used for our analog sound in the previous tutorial. So we do need to take the headphone signal. We then need to use two resistors to combine that into a mono signal, and then we can feed that into this mono amplifier, and of course that then powers our loudspeaker from there. So to get our little test bed up and running, I'm building all this up on some breadboard. But the final idea would be that once we have a circuit that we know works, we'll eventually design a custom PCB and mount all of the circuitry onto that, and then install that inside our case to complete our handheld device. So now that we've got some hardware connected up, we do need to get this I2S signal out. So by default, the Raspberry Pi doesn't have that I2S signal available on the GPIO pins. So we do need to have some extra software which will help us configure our GPIO pins and then generate this I2S signal, which we can then take and feed into our hardware. There is a very good tutorial on the Adafruit website for their I2S amplifier boards. But when I went through that, I did have a couple of problems. So I've gone through my version of it in a bit more detail here on this tutorial. And also, if you go to my project page on my main website, you'll find it all detailed out there as well, with more information about the circuitry, the connections, and this particular version of putting it all together. The main issue I had, especially with Adafruit's fast installation script, which tries to do everything for you, it seemed to depend very much on what I'd been doing with the Raspberry Pi beforehand. So obviously I've been having a play around with the analog audio and the LCD screen and the GPIO Next game controller. If I had been working with that, it did seem to drop me into a strange state where the sound software wouldn't run under normal user permissions. I had to use this, this idea of this sudo to raise my permissions level up to super user before it was able to access all the files it needed. It kept giving a file not found error if I tried to run it just as my normal Pi user. And of course, when Retropie runs, it doesn't run as a super user, so it as well wasn't able to get any of the sound to work. So my take on this is that if you can start with a clean installation of Retropie, which you've built up, I made a new SD card, added the LCD software, the GPIO Next software, but missed out the step on the analog audio software. And then installing this I2S software through the manual setup seemed to give me a much more reliable means of getting it to actually work. So setting up our software then is really in two steps. The first is to disable the analog sound software, and then to make sure that none of the packages that we need to use for our I2S sound are being blocked. So let's have a look at that bit first then. So there is a file in your /etc folder in the modprobe.d folder, and then there's one called raspberryblacklist.conf, which is a configuration file which tells the system when it starts up which particular software modules it should ignore. So if we edit that file using nano, you will probably find that this file is empty, and in that case just press Ctrl X and that's fine. But if you do find some modules being listed in here as being blacklisted, then it's these three here that we need to make sure are not being stopped by the system. So make sure you just put a hash in front of any of these lines, and that will just comment that line out and let that module be loaded by the system. To save this file, of course, in nano, do Ctrl X to exit out of nano, and then if you have made changes, it will then ask you if you want to save those. So just say Y, and then just press return when it says to save it with the same file name. We next need to make sure that our analog sound coming out of our headphone socket is disabled, because obviously that will just get in the way of us doing any I2S sound. So we need to edit, so sudo nano and then /etc/modules, and this is a file which lists the various modules that are going to be loaded in by the system. Now there'll be a couple of them probably already in there, especially if you're using Retropie, but the one which controls our analog sound is this BCM2835 driver. So if you see that listed in your file, just simply put a hash in front of it and that will remove it from the loading process. And again then Ctrl X and Y to save that file and exit out. That really removes any blockages to our I2S system. So we've taken out any of the modules that could be stopped from working, and we've removed any modules that would get in the way. We now need to configure the actual software that we are going to use. So this is going to use the ALSA project software, and that will help us drive the I2S signal and also the sound system itself. Now usually this is installed by default into your Raspberry Pi or your Retropie installation, but we can make sure that that is installed and that everything's up to date by running the sudo apt-get install ALSA utils command. So once that's installed, we then need to create a configuration file for the ALSA system. And this defines a number of audio devices, how they should be set up, and then we need to define a mixer device which will allow us to control the volume and so on. So that file needs to be created. So if we do a sudo nano, it's in the etc folder and it's the asound.conf file. Now inside that, really the easiest way is to simply paste in this block of code. And again, all of the code that I'm using and all the commands I'm using in this particular tutorial, you'll find them all listed out on the main project page for this in my website. And again, I'll put links for that in the description down below. But really what's happening here is that we are creating an alias called speaker bonnet, which is attached to our hardware driver. We're then creating a mixer device, which will allow us to talk to this hardware device and set its volume and so on. Some control hardware, you see there the software volume system which slaves the mixer device, and then down the bottom we are defining or the default hardware device which will then connect it up with the bits we've just defined above. So that really, as I say, there's a lot to this file in setting up our ALSA code, but you can get more information on that. Again, I'll put links to the ALSA project in the project page on my website, and you can get more information about exactly what's going on in this file. But that's the essence of what's happening. We are defining our default driver hardware, and then we are attaching certain software devices to that to allow us to control it better. The last bit then is to enable the correct bits of software on our boot up files. So we need to edit our /boot config.txt file. And if we look in there, if we scroll down, you may well see a line that looks like dtparam equals audio equals on. And that is the line which actually loads in our analog audio system. And we need to, of course, make sure that's commented out. So just put a hash in front of that. Then at the very bottom of our file, we need to create or load in a couple of tree overlays, which will actually run our I2S sound and put that out onto our GPIO pins. So again, all of this code is on the main project page on my main website, so don't worry about taking it off the screen. It's all on there for you. So we have two overlays to load in there, and once you've added those, again, we just need to save this config.txt file, so Control X and Y and enter. And once we've done that, everything's now set up, so we need to reboot our Raspberry Pi, and then we can start testing to see if everything is working. So to test, we can use a little script which provided by our sound system called speaker-test. So if we use the command from the terminal, speaker-test and then -C2, this will produce some white noise, which is in effect a hissing sound, and it will come out of alternately our left and right sound channels. So if you plug in some headphones, you should be able to hear that in one ear and then the other, or if you're just playing it through our mono speaker, you'll just get a hissing sound. But if that happens, then we know that all of our hardware is working. We can then try a more complicated speaker test using a WAV file. And again, there's a few WAV files which come as part of the ALSA installation. So again, we're going to use our speaker test script with the -C2 parameter. And then we're going to do a --test equals WAV to say that we're going to play a WAV file. And then we'll specify that file by doing the -W and then this address here, which will be one of the standard test WAV files downloaded with your ALSA package. And if that's all working, then you should be able to hear a lady saying front, center repeatedly. And so hopefully you'll be able to get everything all working. If not, then please do go through and check through all the steps that we've been through. Check all your wiring and all of the software installations. As I say, I did find that this software installation, if I hadn't got everything correct or if there were certain things lying around, then sometimes the system would either crash when I tried to play a sound, or I would have to use sudo to run the speaker test. So if you find that the speaker test gives a file not found error, try running it with sudo. So sudo speaker-test -C2 and see if that works. If that is the case, then there is a permission area, and I'm afraid I wasn't able to get to the bottom of exactly where that permission was. So I found the easiest way was to just simply rebuild Retropie from scratch, add in all the bits and pieces, and then go straight through and set the sound up, and that reliably got me a working system. So the last thing we need to just have a quick look at on the terminal line is adjusting the volume. So the ALSA package again does have a mixer controller, and again you remember when we set up the A-Sound configuration file, we did attach a mixer onto our hardware. So if you use the command from the terminal ALSA mixer, this will bring up the volume control, and you should then find that we have a volume control little diagram up here. And if you use your up and down arrows, you can adjust the volume. So the idea here is you start up ALSA Mixer, go in and adjust your volume. You can go back and check those the speaker test files to see what the volume sounds like. And once you're happy, we can then save the current volume settings as a default using this line here. So the sudo ALSA control store. And that will then save that for the next boot up. So that gets the I2S sound working on the Raspberry Pi itself. But of course, in my particular project, I'm going to build a handheld gaming console. So I'll need to get Retropie set up as well. And that's the very last thing that we need to do. So coming into Retropie, if we head across to our settings and our sound settings, there's a couple of bits that we need to make sure have the right values. So for audio card, again, there's a number of devices in there, and we need to select default. For our audio device, again, these are the different devices in the system. We need to make sure we select PCM, which is the I2S device. Then down the very bottom, we have our OMX player audio device, and that should be left just as both. So coming back out then of our settings screen, we should be ready to play our games with full digital sound. So there we have our I2S digital sound all up and running on our games console. So for this games console then, with this addition of this digital sound, we now have the full system and it's a fully playable handheld retro games console. But of course at the moment it still relies on USB power. So the next step then is to add in some battery power where we'll be able to recharge them using the USB connection, but also then play the game console while we're doing that recharging. But of course that's going to be in the next video. So if you've liked this one, please do click on that like button, as that lets YouTube know that I'm actually making some useful content. If you want to have access to all of the next videos as they come out, please do click on that subscribe button. So I hope to see you very soon in the next video, and bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.